Okay, now questions based on second law of thermodynamics. Question number 2.117. Find the efficiency of a cycle consisting of two isochoric and two adiabatic lines. If volume of the gas changes 10 times within the cycle, then the working substance is the nitrogen. Right. So here we have a cyclic process that consists of two isochoric and two adiabatic process. So first let's draw the PV diagram. This is P and V. Here are two adiabatic process and two isochoric process. Right. So this is volume V1, this is V2, and V in this question it is given V2 is equals to 10 V1. Right. And secondly, another information is there given that work substance is nitrogen. So it means nitrogen is N2, so it is diatomic. And we know that for a diatomic gas, the gamma is equals to 7 by 5. Okay. And we'll do the rest part later. Now see, if this stage is P1, V1, okay, and this stage is P2, V2, right? And at this point, this is P3, V2, and here it is P4, V1. Now these two processes are adiabatic, so there will be no heat exchange would take place. Okay, we can make this cycle. Now suppose here heat is coming Q1 and getting out from this system is Q2. So first of all we need to calculate the Q2 and Q1. So Q2 would be definitely when process is isochoric, then work done is equals to 0. So heat supplied or heat loosed by the system is equals to change in internal energy. So this is CV and delta T, right? We are taking 1 mole. Okay. So to keep it simple, this is CV into delta T. Okay. So at this stage, temperature, let's also mention the temperature T2, T3, T4 and T1, because in adiabatic process, all variable changes. Okay. So we can write Q2 is equals to CV, and for this process, T3 minus T2. This is our first equation, right? Now, although if we want, then we can replace this T in terms of pressure as well. Okay. As PV is equals to nRT, and for single mole it is RT. So we can write T equals to PV upon R. Right. So this Q2 can be written as volume is V2, so CV into V2 into P3 minus P2 over R. Okay. This is our primary exercise for the first step. Now similar fashion we can calculate Q1. So in this case you can directly put this is CV, volume is V1, pressure is changing from P2, P4 to P1, so we can write P1 minus P4 upon R. Okay. Now see, if we calculate efficiency of the system, then efficiency is work done upon heat supplied, and work done is definitely that Q2 minus Q1, okay, like Q1 minus Q2. So work done is Q1 minus Q2 and heat supplied is Q1. So our efficiency is 1 minus Q2 over Q1. So let's resolve this expression by substituting value of Q1 and Q2 from this expression. So our efficiency would be equals to 1 minus B2, P2 minus P3 upon V1, P1 minus P4, right? So this is expression for the efficiency. Now yet we don't have idea about pressure and volume, how pressure is changing. But these two steps are getting connected by to adiabatic process. And in adiabatic process, Pv to power gamma is equals to constant. So we can write for adiabatic process P1 V1 to power gamma is equals to P2 V2 to power gamma, and similarly P3 V3 V2 to power gamma here to here, that is equals to P4 V1 to power gamma, right? So if we just rearrange this for the sake of simplicity, that is P3 into V2 to power gamma. Now see, here we can write P1 minus P4 into V1 to power gamma is equals to P2 minus P3 into V2 to power gamma, right? So from here we'll get very interesting relation that P2 over P3, P2 minus P3 over P1 minus P4 is equals to V1 over V2 to power gamma, right? So in expression of efficiency, we can replace this term, right? So if you replace here, then you will get efficiency is equals to 1 minus V2 over V1, and this is V1 over V2. So if you write V1 over V2, then we can write this is V1 over V2 to power gamma minus 1. Agree? This is V1 over V2 and this is V2 over V1. So 1 power will get reduced. And this relation is given that V2 is equals to 10 V1. So we can write V1 over V2 is 1 over 10. Okay. So this efficiency is equals to 1 minus 1 over 10 to power gamma minus 1. Now this is nitrogen. Work substance is nitrogen and gamma is 7 by 2. So this is 7 by 2 minus 1. 7 by 2 minus 1 is equals to, 7 by 5 minus 1. So this is 2 by 5. Okay. So from there we'll get efficiency is 0.602, or if we convert in percentage, then this efficiency will be 60.2% for this engine.